Hello, how's it going? This is the introductory video for using the LabJack U3 device that you can use instead of the National Instruments setup. It's about 1/10 of the cost, and there's the capability is still there. In some cases exceeds that, specifically for using this system to collect high frequency voltage. Some of the modules we've got are universal for the National Instruments. Not that they can't do it, but you have to get a different module. But in this case, LabJack does a good job for pretty much everything. You'll see that as you use it. So here's the LabJack module. You have, this is digital outputs that can go from 0 to 5 volts, I believe. These are analog inputs from negative 10 to 10 volts. And these F ports, as well as the E's on the extension, those can be digital outs, ranging from like a 0 to 1 kind of a scenario, or analog inputs. And I'll show you that screen to set those because they're kind of variable. And then here's your 24-volt power supply. In some cases you'll need that. And then you have your connectors here for easily connecting wires to the 24-volt power supply or otherwise. And here is the website to install the software from LabJack. It's free, and there's Windows and Mac OS versions, and you have to make sure you get the one for U3, and there's 2 of them you'll want to use. It's the LJ control panel and the LJ log UD. Those 2 you're going to use. I think when you download it, it comes with several other software pieces, but those are the ones we're going to use. So if you click on LG control panel, after you plug in your USB port from the LabJack, and there's a little light on the extension that shows it's on, you'll get that screen, and you can see that there's the USB port, and then you can test it right here. And you can see that there are the analog in 0, 1, 2, 3. That corresponds to over here 0, 1, and 2, 3. G and D is ground, VS is the voltage, the power supply for the voltage. And you can see it's measuring right there, 1.3 volts. And then we can also change, like I said, analog input, digital input, or digital output. So we're going to change EO 6 and 7 for thermocouples with our amplifier. That's on EIO 6 and EIO 7. So we're just going to click those, show that they're analog inputs, and I'll start to read them. And you can configure that so when you use Python, it just knows the channels, that those are channels 14 and 15, that they're you're reading instead of sending a signal. And this DAC 0, you can see DAC 1, that's the analog outputs, not digital outputs, but analog outputs. That's these guys over here, DAC 0, DAC 1. So that's for like controlling your valve, the opening position. And so yeah, once you do that, you can set these guys there, 14 and 15. You see that it changed it to 14 and 15. You can exit, and then you can configure defaults. So like you'll see that right there, EIO 6 and 7, those are now analog inputs, and you can like write values so that it remembers what they are, like when you're using Python, and it'll do that for you. So that's that, and you can exit. And then the LabJack, that's pretty much all you need to do to use Python, but you can use this log UD program, and it will show you what is being recorded. So you can see that you can specify the number of channels over here, and you have to do all 16 to get 14 and 15 down here. And you can specify an interval, collection interval, and you can even have it write data, collect all of these, and turn on which one you want to plot and what that values it's reading, so on and so forth. So that's a tool that you can use, but I think you'll want to use the Python logic and write code to control your system, and that's explained in other videos. But we'll make these example sheets on how to connect to it and so forth available to you. God lives and loves us.